The data that I'm going to be presenting is we conducted some of the surveys in 2002 in the Caribou and Thousand Lakes wilderness areas, and we partnered with the California Department of Fish and Game for that work. And then using essentially the same protocol, in 2004 we conducted the surveys in Lassen Volcanic National Park, and our partners there were Southern Oregon University, Lassen National Park, and the Klamath Network of the National Park Service. And then all the other people there were also crucial. So going into the surveys, we had some background. We knew from Fellers and Drost that they revisited a bunch of sites where Cascades frog had previously been common in Lassen Volcanic National Park, and they documented some precipitous declines. There's also been a lot of other survey work on the forest and in the region, and it seemed like Cascades frogs were very few and far between. So we went into the surveys knowing that. And just a nice photo so you guys could see some of the animals, cast of characters. And the big question on our minds going into this was, are we going to see any Cascades frogs? The survey methodology probably looked pretty familiar to this group. It's been used to document the impacts of fish on amphibians in the West, in a lot of places in the Sierra Nevada, other areas in Northern California. We've conducted these surveys in the Klamath region. We use time visual encounter surveys to detect amphibians and reptiles, mostly garter snakes. Gill net surveys to document the presence of fish, timed gill net sets, unless fish absence could be determined visually. We collected quite a bit of habitat data. And this, in Lassen Volcanic National Park, we did invertebrate surveys, which I'm not really going to be speaking about. That Michael Parker and his students at Southern Oregon University are taking the lead on that part of the work, and we'll probably hear more about that in the future, but they're still working on that. So you can see we've got Thousand Lakes Wilderness, Caribou Wilderness, and Lassen Volcanic National Park. And we surveyed 898 unique sites between those three areas. Some sites were surveyed a second visit, but that's the total number of sites there. In Lassen Volcanic National Park and Thousand Lakes Wilderness, we surveyed all map sites as well as all sites encountered incidentally while traveling between map sites. And that includes lakes, ponds, and wet meadows. In the Caribou Wilderness, we use the same methodology, but we didn't complete the wilderness. So we surveyed 455 unique sites, but 196 map sites were not surveyed there. Pacific tree frogs were the most common amphibian detected, 491 sites. That's about 55% of the sites surveyed, and they're in all three of the study areas. 37 sites with western toad, much fewer sites, but still in all three study areas. And some of the sites within Lassen Volcanic National Park were pretty incredible with thousands and thousands of metamorphs coming out of them. So some really big breeding populations in the year that we surveyed. 115 sites with long-toed salamanders. Typically smaller populations with less than 100 larvae. And we did see in Lassen Volcanic National Park a few times we encountered sites with really high numbers of dead larvae. And we did send some of them for testing. We didn't find any pathogens, but whether we were looking for the right things or not, we don't know. And Cascades frog, you'll notice that that Caribou and Thousand Lakes Wilderness areas aren't really depicted on this map because we didn't find any Cascades frogs in those areas. And in Lassen, we found a total of 4 frogs depicted there in the lower right-hand corner of the park. So 3 different sites. 2 of the sites had 1 frog. 1 of the sites had 2 frogs. There may have been 2 frogs here that went basically unidentified despite repeated visits. And that's it. No breeding, no larvae, despite repeated visits to the areas where we did see frogs. And so part of the goal of this was to also look at the distribution of fish among these areas and to evaluate how they might affect the distribution of amphibians. All three of the areas used to be fishless, or at least primarily. There may have been a couple of lakes within these areas that had fish historically. In Lassen, it's kind of interesting because the stocking was scaled way back in the 70s, and by 1980 it had been completely terminated. So we found that a large percentage of the sites that had been historically stocked had reverted to fishless condition. But we did still find 23 sites in the park with fish. And of course, fish are present in a lot of the streams, and those were not really surveyed by us. The fish were the usual fish. We have brook brown and rainbow trout, as well as a number of minnows that were probably introduced as bait fish. So we looked at the effect of fish on amphibians. We used non-parametric regression and generalized additive models to assess the landscape scale patterns of distribution of fish and amphibians. That allowed us to control for the habitat variables and estimate the likelihood of finding the various amphibian species in the presence of fish. These are what we consider the palatable amphibian species. And we found that long-toed salamander was 9 times more likely to be found in fishless water bodies than water bodies containing fish. Pacific tree frog, 3 times more likely to be found in fishless water bodies. And Cascades frog, with only 4 frogs in the park, we weren't able to analyze that statistically. But we do know from the Klamath surveys and the data that we have there that Cascades frog probably lies somewhere in between Pacific tree frog and long-toed salamanders in terms of its likelihood to be found in the presence of fish. So, one question that we asked after collecting all this data is, are fish the primary driver of the observed declines, the declines that were observed previously, and apparently the frogs haven't recovered. And we know that the fish are adversely affecting Cascades frog, but for a few reasons we don't believe that they're the primary driver of the declines seen in the Lassen region. For one thing, fish are much more common in the Klamath region. There's 85% of the lakes in the Klamath region have fish versus 16% in Lassen Volcanic National Park, but Cascades frog is doing much better in the Klamath region. Also, from our models in the Klamath region, long-toed salamander is much more sensitive to fish, and it's also our models from Lassen show that long-toed salamanders are sensitive to fish there as well, but they're doing much better than Cascades frog, and because the models show they're more sensitive, if fish were the primary driver, we'd probably expect them to also be showing severe declines. And then finally, the order of events for the Lassen region doesn't really implicate fish because Cascades frog was doing relatively well through decades of regular fish stocking, and it wasn't apparently until fish stocking was terminated that these declines were noticed. And now we've had about 30 years with no fish stocking and fish disappearing from lakes, and the frogs haven't recovered. It leads us to conclude that there must be some other stressor that's responsible for these declines in addition to fish. And so just in summary, we know that Cascades frog was historically abundant, locally abundant, at least in some spots in the park, as recently as the 1970s. We know that the declines detected in 1989 were severe, and from our surveys, we believe that the frogs haven't recovered. It seems like the frogs are nearly absent from Thousand Lakes Wilderness, perhaps Caribou Wilderness, and just barely hanging on in Lassen Volcanic National Park. Surveys on the National Forest, there's a few breeding populations, but it's a similar situation. And we conclude that fish are not likely the main driver of the observed declines. And that's all I have. You know, chytrid hasn't been detected in any wild populations of Cascades frog, but some recent work by Blaustein, he was able to grow chytrid on some Cascades frogs, but it didn't seem to reduce their survival. The pattern of decline seems to fit the disease hypothesis where it was very sudden, but other than that, you know, there's no direct evidence.